Today we study Millikan oil droplet method. Millikan successfully find charge on electron in 1909. Let's see his experiment in 3D in order to better understand this experiment explanation. Millikan took a table for his experiment as you see in the screen. He place a closed cylinder above that table. He use closed cylinder in order to save from air current. Then he placed a plate inside the cylinder like that. Then he took one more plate having a tiny hole on its center. Let's see this plate from the top side as you clearly see a hole inside that plate. In order to provide voltage, he connect lower plate with the negative terminal of the battery, and upper plate with the positive terminal of the battery. He took an atomizer. Atomizer is a device for emitting water, perfume, or other liquids as a fine spray. He also place a microscope in order to examine the motion of that spray. First called this upper plate to P and lower plate to P'. Distance between the two plates is denoted by D, and the voltage between the two terminals of the battery is V. As he pushed the atomizer, small tiny spray particles spread out inside the cylinder. Some of the particles passes through the upper plate hole as you see in the screen. In order to ionize that liquid. Ionize means to separate the particles into positive and negative ions. Millikan take advantage of X-ray in order to ionize that liquid particle. Then he observe the ion's motion through his microscope. He used that concept. If we make such a condition that the force acting on the charge due to electric field F is equal to QE becomes equal the force acting on the charge due to gravity F equals to mg, then the charge gets suspended in the air, and he put down the two equations like that. As we know, the electric field or electric field intensity is equal to voltage provided to plates divided by distance between that plates. He also noted down that equation. By comparing these equations we get the following results. Then he turn off the battery. On that spot the particles gets uniform velocity, and now the particles experience force F equals to 6 pi eta RV according to Stokes' law. By comparing the equations we get the following results. Then we put the mass equation in the above result. From that equation we determine the radius of the particle and place it in above equation. Place that m value in equation 5. Millikan get the charge on the electron as Q equals to Ne, where n is integral multiple of any number, and he find charge on electron as 1.6 multiply 10⁻⁻19 c.